Hello students, let us discuss valence or the oxidation state in the chapter Classification of Elements and Periodicity in Properties. As we have already discussed that atom consists of nucleus and electrons are revolving around the nucleus. The electron which is in the outermost shell, these electrons are called as valence electrons. So how you define valence electron? Valence electron is the electron in the outermost shell, or we can say the electron in the outermost energy level of an atom is called valence electron. The electron present in the outermost shell, which is called as valence electron, are most important property because it is observed that the chemical properties of the elements depends upon the number of electrons present in the outermost shell, that is the valence electrons. Let us consider elements of second period in a modern periodic table, that is lithium, barium, boron, carbon, nitrogen, oxygen, fluorine and neon. Here the outermost shell I have represented in terms of dot. So lithium have a single dot. It represents that it have only one valence electron. Beryllium have two dots, two valence electron. Boron, three valence electron. Carbon 4, nitrogen 5, oxygen 6, fluorine 7 and neon 8. So when you look at here, the group number for this lithium is 1. So how you find out the valence electron? If you are familiar with the position of element in the periodic table, that means if an element belongs to group 1, it having 1 valence electron. If an element belonging to group 13, then it have 13 minus 10, that is equal to 3 valence electron. If an element belongs to group 15, then 15 minus 10, that is equal to 5. So 5 is the valence electron. So tell me what will be the number of valence electron for an 18 group element? That is 18 minus 10 equal to 8. 8 is the outermost electron in the noble gases, that is 18 group element. That electron is called as valence electron. So here I am taking the two examples, sodium and chlorine. If you are familiar that the position of sodium and the chlorine in the periodic table, you can easily tell the valence electron present in these. So first of all, try with sodium. Sodium belongs to which group? Definitely it belongs to the group first. So what will be the number of valence electron? That will be 1. What about Cl? Chlorine is a halogen. So it belongs to group 17. So 17 group means 17 minus 10, that is equal to 7 is the valence electron for chlorine. So let us check the answer while making the diagram structure of sodium and chlorine. When we make, it will be in this way. Atomic number for chlorine 17, atomic number for sodium 11. When you make the electronic arrangement, it will be in this way. Now let us count the number of valence electron. That means electron in the outermost shell. In both the cases, 3 shells are there. So let us count the outermost shell. Let us mark the outermost shell with the red color like this. Now you count it very easily. So there is a single electron in the sodium in the outermost shell. So therefore the valence electron for sodium is 1. And for chlorine, there are 7 valence electron. So I told you, you have to find it out the valence electron on the basis of periodic table. So let's have a look about the periodic table. For important elements, that is a representative element, So look at the first group element. In the first group, hydrogen, lithium, sodium, potassium, rubidium, cesium all have single valence electron. So the group number 1, so the valence electron is 1. What about the second group? Second group, beryllium, magnesium, calcium, strontium, barium. These belong to second group, so therefore valence electron for these are 2. 13 group, boron, aluminium, gallium, indium, thallium. Here they are belonging to 13 group, therefore 13 minus 10, that is equal to 3. So 3 is the valence electron. Similarly, 14 group have 4, 15 group have 5, 16 group have 6, 17 group have 7, and 18 group have 8 number of valence electron. So on the basis of the position of an element in the periodic table, you can easily identify its valence electron. So valence electron is clear, that is the number of electron present in the outermost shell. What about valency? Valency, the word is familiar to you, valency. Let us discuss what is this valency. The valence electron for the two atoms which we have taken here, that the hydrogen and oxygen, the valence electron for hydrogen is 1 because only single electron is there, and for oxygen it is the valence electron is 6. But what is the valency for these atom? That is, in order to form a stable configuration, that is the first shell, the completely 2 electrons should be there in order to fully filled. So hydrogen require a single electron, but the oxygen require 2 more electron in order to complete the octet. So that means in order to stabilize, hydrogen require 1 electron to get stable and oxygen require 2 electron to get stable. So the valency for hydrogen, because it requires 1 electron to get stable, the valency for hydrogen is 1. But the oxygen requires 2 electron in order to get stable, therefore its valency is 2. So from this, what is clear? What is the valency? The valency, the capacity of an atom to give, accept or the share electrons to achieve the octet state. That is called as valency. The valency is the combining capacity of the atom. So that number is the number of electron gained, loosed or shared by the atom in order to form a stable configuration. So let us check what is the valency of an element belonging to second period element, which is given here. Lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the elements of second period. In this chart, group the number of valence electron and the valence is given. Valence is nothing but the valency. Valency can be written as valence. Here, the first group, second group, 13 group, 14 group, 15 group, 16, 17, 18 group element. So the number of valence electron just now we have discussed 1, 2, 3, 4, 5, 6, 7, 8. But what about the valence? When you look at the valence, here the valence increases from 1 to 4 and afterward it decreases, because after 4 you can see 3, 2, 1, 0. That means the valence increases from 1 to 4, then it decreases 4 to 0. Because the elements can show multiple valence, therefore the nitrogen can show the valence 3 also, 5 also. Oxygen can show 2, 6. Fluorine can show 1 and 7. So this is what actually the valence, that is the valency goes in a period. And the element belonging to the same group will have same valence. Like the case of sodium, sodium also have the valence, that is 1. The valence for sodium is also 1. Like magnesium belonging to the second group, its valence is 2. So the valence or the valency is also in the period and the group wise it will be same. So the valence or the valency of a representative element is usually equal to the number of the electron in the outermost orbit, or equal to the 8 minus the number of outermost electron as shown below. That means what it shows that valency can be equal to its valence electron for the representative element. These belong to the representative element. So when you look at here, the valence electron, in some cases like lithium, valence electron and valency is same. Beryllium 2 2 same. Boron 3 3, that means valence electron and valency are same. For carbon also valence electron is same as valency. But look at the other case, nitrogen. In the case of nitrogen, the valence electron is 5, but the valency is 8 minus the valence electron, that is equal to 3. So the one valency which it can show is the 5, the other one is 3. So how we can find out the valency? The valency can be equal to the valence electron or equal to the 8 minus valence electron. So let us find out the valency for the case of fluorine. Fluorine belongs to group 17. So what will be the valence electron? The valence electron is 7. So how you find out valency? The valency is equal to, that is a valence electron, that is equal to 17 minus 10, that is equal to 7. So valence electron is equal to 7. So it can show 7 valency also, but it shows another valency, that is 8 minus the valence electron, that is 7, is equal to 1. So what are the two valency? 7, 1. Check here, that is 1 it also shows, 7 also show. So how you find out the valency? The valency is equal to the number of electron present in the outermost shell, that is nothing but the valence electron, or it can be equal to 8 minus the valence electron. Nowadays, the term oxidation state is frequently used for the valence. So the valency can be used, and another word for valency, that is oxidation state. Now with the help of these valency, we can find out, or we can construct the formula for any compound. Now let us construct some formulas. Let us take an example, carbon and hydrogen. What will be the formula between the carbon and hydrogen? Depending upon the valence, we can make it. What is the valence for carbon? That is 4. 4 is the valence for carbon, and for hydrogen that is 1, because it belongs to, you can consider it has to be in the first group. So 1. Now cross multiply it. When you crisscross it, you will get the formula CH4. So CH4 is the formula which can be formed between the carbon and hydrogen. Let us take an example. The example of beryllium and hydrogen. What is the valence electron for beryllium? That is a valency, and the valence electron is same, that is 2. Hydrogen 1. Cross it, you will get the formula BeH2. So in this way we can make the formula very easily for the binary compounds. That means the compound made up of 2 components. Let us take one more example. The example, that is boron and fluorine. Let us make the formula for this one. Boron and fluorine. Boron, valence electron or the valency is same, that is 3. Look at the chart. 3 is the valence electron and 3 is the valency. So valency is 3. But fluorine 1. So when you crisscross it, you will get the formula BF3. So that is the formula for BF3. So the more details about why it does not form 7 oxidation state with boron for fluorine, that will be discussing in the chapter that is P block elements. So let us take the more important example which is given in the textbook, that is oxygen difluoride. What is a oxygen difluoride? That is compound made up of 1 oxygen and 2 fluorine. In this case, because we know that the bonding in which, that is a covalent bonding here. So what will be the charge on the oxygen? That means, does it have a minus oxidation state or does it have plus oxidation state? That we need to find here. So for this you need to compare the electronegativity. We know that fluorine comes on the extreme right side when you compare with the oxygen, because after oxygen only fluorine comes in the periodic table. So I told you fluorine, that is the most electronegative element. So definitely the fluorine will develop negative charge, and in the comparison with fluorine, the oxygen will develop positive charge. So in a compound, one of them will be the positive, other one should be the negative one. So in this case, the fluorine, because of high electronegativity, fluorine develops a negative oxidation state, that is -1 oxidation state. But in compared to fluorine, oxygen is less electronegative. Therefore, if fluorine is developing negative charge, therefore the oxygen must develop the positive charge, that is the +2 charge. So we can say that the bonding takes place in between them, that result in the formation of oxygen difluoride. So it is clear that oxygen here it is positive, not the negative, because the positive and negative are compared, it is with the element which is combining. Here the fluorine is most electronegative than the oxygen. So fluorine is developing a negative charge and oxygen is developing positive charge. Let us take another example. Sodium and oxygen. Sodium, we know that it is on the extreme left hand side. In the periodic table, sodium is on the extreme left hand side and oxygen is at the right hand side. So which is more electronegative here? On the right side, the element is more electronegative. So oxygen is more electronegative. So it develops a negative charge. And sodium, it always develop one positive charge. So sodium have one positive charge. So how you make the formula? That is Na and O. Na have +1 charge, O have -2. That is the valency or the oxidation state. When you crisscross it, you will get the formula Na2O. So what will be the formula of sodium oxide? That is Na2O. So we can say that there is a bonding between the 2 sodium atom with 1 oxygen. So from this it is clear that what is the valency and what is the valence electron. Let us compare valency and the valence electron. Valency of an element is the number of bonds it is able to form around it. So nothing but the valency is actually giving the number of bond which is formed with the surrounding atom. So just like we have discussed here, one sodium can form single bond. So the valency for sodium is 1. But the oxygen can form 2 bond here. So the valency for oxygen is 2. For sodium, 1 sodium can form 1 bond. Therefore the valency is single. So we can also define the valency of an element or the atom is the number of bonds it is able to form around it. And the valence electrons are the electron that take part in the chemical bond formation, that is valence electron. So valence or the valency is the most important property of the element. It has been observed that the chemical property of the element depend upon the number of electron present in the outermost shell. So these are the two important points, that is the valency and the valence electron. Let us do some of the questions related to this concept. Predict the formulas of the binary compounds that would be formed by the combination of following pairs of elements. First one, lithium and oxygen. We have to predict the formula of the stable binary compound from these elements. Here lithium, it belongs to group first, so the valence is 1. Oxygen, it belongs to group 16, so 16 minus 10, that is equal to 6 is the valence electron. So the valency, that is 8 minus 6 is equal to 2. So 2 is the valency. Now when you crisscross it, you will get the formula, that is Li2O. So what is the formula? Li2O. So you have to do in this method. Next, magnesium and nitrogen. Magnesium belongs to group second, so the valency is second, that is number 2. Nitrogen belongs to group 15, so the what will be the valence electron? That is 5. 5 is the valence electron. It belongs to group 15, so 5 is the valence electron. So what will be the valency? That is 8 minus 5 is equal to, that is 3. So 3 is the what? That is the valency for nitrogen. When you crisscross it, you will get the formula Mg3N2. So what is the formula? Mg3N2, that is magnesium nitride. Next, carbon and hydrogen. Carbon belongs to group 14, therefore the valence electron is 4, that is nothing but its valency. Hydrogen 1. When you crisscross it, you will get the formula CH4. That is the formula for compound of carbon and hydrogen. Si and O. Silicon belongs to group, that is 14 group. So 4 is the valence electron, that is nothing but its valency. And oxygen, it belongs to group 16. So 6 is the valence electron, 2 is the valency. Now when you crisscross it, you will get the formula Si2O4. Now 2 is to 4. This 2 is to 4 ratio, when you simplify it, you will get 1 is to 2. So what will be the formula generated now? SiO2. So the formula is SiO2. So in the some cases, you have to do it a simplification, then the formula which is generated, that will be the formula. So the formula for Si and O combination is SiO2. Carbon and oxygen. Carbon belongs to group 14, so 4 is the valence electron. Oxygen, that is 2 is the valency. When you crisscross it, you will get the formula, that is so when you crisscross the formula, we will be getting the formula carbon 2, oxygen 4. Here also you can simplify, that is 2 is to 4. When you simplify, you will get 1 is to 2. So the formula now generated, that is CO2, carbon dioxide. So these are the method which can be used in order to frame the, or we can say predict the formula of the binary compounds. So first you need to remember the position of the element in the periodic table, and if you know the position, you can find out its valence electron or valency easily. So on the basis of that, you can easily frame the product. So this is all about the valency and the valence electron which we have discussed in this video. So it is one of the most important property because the chemical property or the bonding of the atoms in the molecule depends upon this combining capacity, that is valency. So this is all about a valence electron and valency and its periodic trend we have discussed in the modern periodic table. So thank you everyone.